Welcome back, everyone. Today's video comes as a request from Joubert van Zyl. My French is terrible, I probably got that wrong. Sorry, man. But anyway, we're going to be making a radial blur post-process effect as seen in an Unreal Engine 4 forum post, link to which I will put in the description below. And part of how we're going to do this is with a custom node that we're going to make up with some code. It's going to be pretty cool and should produce a very nice effect. So we're not going to need anything to get started. We're just going to have to right-click and make a new material, call it Radial Blur PP, and then open it up and we can get started. So here we are in our material, and so straight away we'll need to set the material domain to a post-process so that it's a post-process material, and then we can have a little bit of a think about how exactly the material is going to work and what exactly we're going to need to work in conjunction with our custom node. For one, we're going to need our scene texture, a scene texture node, so that we can get our post-process input 0. And this will, we just plugged it into color, it just gets our scene to return just the default post-process. Okay, that's easy enough, although we will have to mask this because we won't be able to use alpha. So we'll just mask out the alpha channel, just the R, G, and B. And we'll also need a screen position node so that we can get the actual location of the screen in a viewport UV. Now that that's done, and the sort of function, the way that we're going to make it work, the alpha for our lerp. So we'll have our default post-process going into a lerp, and our radial blur going into the other input of the lerp. As the alpha, we will use a radial gradient exponential, which, if we plug into the emissive, you can see here is just a straight up circular blur, a radial blur, in fact, that we can use here as the alpha value. Pretty simple stuff so far, and in fact, just so that we can make sure that everything lines up properly, we'll get screen aligned UVs and plug X and Y100 into the UVs of our radial gradient. So far, so good. Now we'll make some controls for our gradient exponential, such as blur radius. We'll set this to, let's say, 1. Plug this into radius, and we'll need another scalar. We'll call this one density. We'll default this one to something like 4. And we'll plug this into density. But I noticed that there was some strangeness with the radial gradient exponential. I was getting some different results when I didn't think I would. And when I opened it up, I noticed that in this in this function here, so there's some weirdness. There's some nodes that are just out in the wind that just do nothing. that are just sitting out there. So I don't know what's going on. But I was getting some different results. And what worked for me to get the kind of effect that I liked, so if I come out of my density variable here into a 1 minus before plugging it into density, then the effect worked a lot better. Well, a lot better than inverting the density here with a static boolean. I'm not quite sure why, but yeah, as I said, there's some strange things going on here that I didn't quite understand. So let's move forward. So this becomes the alpha of our lerp. And then we're ready to use our custom node. In order to make a custom node, all we need to do is right-click and type in custom. And there we have it, a custom node ready to go. And over here on the left, we can plug in all the code we want into this little window here. And we have a couple of inputs that we can play with. And now we can talk about custom code. So if you've ever used Unity or like coded shaders in Unity, you might be a little familiar with this kind of syntax. It's called HLSL, High Level Shader Language. And it's what Unreal Engine uses to calculate shaders. And this here, well, full credit goes to Tomura from the Epic Games forums, who originally came up with this code, and then Moadib a few years later, who posted an updated version for 4.18, I think. I'm using 4.20, so this will work. This will work with the latest possible version. So many thanks to everyone that's worked on this so far. I'm not going to go into too much depth here. Like, we're declaring some variables here, some floats, some constants, and then we're performing some calculations here in a for loop. So if you'd like more information on this, I'm going to drop a link to the Epic Games forum post down in the description, as well as a link to learn more about the HLSL language, just in general. So copy this code, grab your custom node here, and dump it into the little code window. Just like that. Easy enough. Now we're going to need some inputs here, so let's make another input. We'll need two variables. And the trick here is to perfectly match the names of your inputs to the variables that you want to be providing information for you've declared in your code. In the case of this this piece of code, those are blur dist and screen UV, just like that. So yeah, the important thing here is to make sure that we're matching the names of our variables absolutely perfectly. Otherwise, the code just simply won't work. These variables won't be corresponding to anything. And we'll give it a name, a description here. We'll call it Radial Blur. All right, with that done, let's get our screen position, get our viewport UV, and plug it into the screen UV. And we'll also need a scalar to be our blur dist. So we'll just make that blur, we'll call it R1, plug it into blur distance, plug in our custom node into B, and then our mask out of the scene texture node into A, and then our lerp into emissive. And there we have it, showing up straight away. So there are already some limitations that might be readily apparent. For example, around the edges here, around the right hand and the bottom edge, this is just a side effect of using the screen UVs, really. We could expand the screen size and try and eliminate this if you want some really radical blurs. But for the sake of this video, we're just going to put up with it. So hit save and head back to the editor. Okay, now that we're back here, let's find something that we can drop in the scene so that we can have a look. So let's get our third-person idle animation. Let's focus in on him like that. And then we'll head up to the world outliner, find our post-process volume, and then find our materials, add an element to this array, make it an asset reference, and then we'll find down here in materials our radial blur post-process material. So we'll right-click this, make a new instance, drag this over here onto this gray box, and there we have our radial blur affecting in the world. And we can see it in the editor here. So let's open up this instance and we'll talk about some of these values. Tick all these boxes. So the blur radius and the density are the values that are controlling our gradient exponential. So if we change these, the density is the one that you'll use to control the blur in a general way. Then we have our blur radius, so we can drop that down to 0 or raise it back up. Leaving it at 1 really is the way to go. Then there's our blur value, which controls our custom node, and you can see the higher we set this value, the more radical our blur is going to appear. It's pretty cool. Let's see, what else can we do with this material? Well, we can invert it in a way, like if we swap out this mask for the B and the custom node for the A, and then if we skip this 1 minus and hit save, then back in the editor, we can have another little play and see what we can do. So now the density is working in the opposite direction, and the blur is sort of more radically affecting the edges. Instead of sourcing from the center, it's now sourcing from the outside coming in. And we get some very, very cool effects here. We raise up the density, so it's affecting most of the edge now and leaving a lot of the center unaffected. Just like that. Very, very cool effect. And that's about the end of the video, guys. So I'll correct this I'll set this back up the way I had it before, because I like the way it was at the start. We'll hit save on that. So yeah, this is how to make a radial blur with a custom HLSL code node. I thought this was quite fun, pretty interesting, and a good example of how you can inject your own code into an Epic Games or an Unreal Engine 4 shader. This is pretty nice. So thanks again to Joubert van Zyl for sending me the request, and also to Tomura and Muradib from the Epic Games forums for coming up with the original material and then refining it for the later editions of the engine. So let's have one last play, and then I'll see you guys next time.